Here it goes. Okay. So section 3.3 was percents. That's what was supposed to happen yesterday, but I had to not have class, so there was no class yesterday. Meanwhile, all the grades are updated completely. So if you get a chance to check the Genzabar grade book and verify, make sure I didn't mess anybody's up or miss something. Every now and then somebody will text me some work, which is fine. It's a small class, no big deal. But if I might overlook it, I apologize in advance if that ever happens. But just remind me if I overlook it, and I'll update it. Or somebody might post something on Moodle that I missed, or send me an email. Like I get stuff in email, like a Google document share. Sometimes I get it on my phone. Sometimes you send answers in the chat that I miss. So if anything like that happens, just let me know. Oh, thanks, Shanda. What a great word of encouragement. Give you. There we go. Very nice. All right, so the problem I was going to start off with that someone asked me was, and we'll do some more too, like I said, 37 is what percent of 5,550? So starting off strong, because I know everyone could handle it. There's like 3 different kinds of percent problems, and this is one of them. What we're missing is what percent. We're looking for the percent. We take the number that's the part, or it's with is, and we put that over the number that's the whole. So we're looking for what part of 5550 is 37 really. That's what we're trying to figure out, what percent. So I am so glad this person asked me this one, because it's one of the hardest ones on that assignment, and it covers a lot of the issues. So there's 2 ways we could do these. I'm going to do it this way. And we're looking for that missing number. I'm even going to call it a variable, because we've already been solving problems with variables. So that's what X is going to be the answer. Anything over 100 is a percent. So we can cross multiply. This is something we're going to be doing today. And cross multiply here. 5550X. You might have done this in the past and already know how to do it in just one step, but I'm just showing, oops, yeah, this is right. And divide both sides by what's with X. I'm just showing the full thing right now. And then we want to figure out what number does that equal. So we would need to reduce it all the way down. So I would say that's why this is one of the hardest ones, right? So X equals, right away we could cut the 0 off, divide top and bottom by 10. And then we want to break it down even further. So I think I could divide the top and bottom by, what do you guys think? What's a number that could go into both of those? I did this already yesterday, but I didn't do it this way. So I'm just trying to show a different way. Like 5 could go into both, but can anybody think of anything bigger? It's not obvious. We might as well just go by 5. So if we did it by 5s, 37 divided by 5 is 74. And 555. And then it feels like it's done. And that's what's so confusing about this one. So if you got that far for your answer, x equals 74 over 11, that's correct. It's just not all the way reduced. It's very sneaky, tricky one. Did anybody get the number it could break down by further? You can just let me know if you did, or you might have had different numbers in your problem. 37 goes into both of them. I would never put this on the final, for example, because that was just like pure evil. The greatest common factor, or the greatest common factor is 37. Yeah, good, Shanda. Woo! 5 points for you. Yep. So it comes out to be 2/3. So 37 is 2/3% of 55550. There's another way to do it. So I'm going to show the other way too, just in case you've been working on that way. It wouldn't be wrong to get a decimal and then change it to the fraction, but it's a little confusing. I'll show you what I mean. I mean, this was confusing too. But before I show the other way to do this one, does anyone have a question about the steps that I just did? I'll just review it too. Here's the setup. Is in the of something over 100, that's the percent. And then we cross multiply because it's like a, it's called a proportion, one ratio equal to another ratio. And we're going to study those today. So then we get to this equation and then solve it. That was here, and then reduce. So that was cute. Thank you for asking me that. You know who you are. But I'm going to show it in this way. You also could go 37 divided by 5550, which most people would be like, this is going to be easier. And we get 0.006 repeating. That, if you write that in the WebAssign, it's not going to give you credit for it. There are math teachers that would give you credit for that. And that's not even as a percent, because first, that's not the answer. Then you have to, like, if we back it up, if we had 4/5, what if we wanted to write that as a percent? 4 divided by 5, I'm just backing up the truck for a second, would be 0.8. But then when we want to write it as a percent, we move the decimal 2 to the right. So that would be 4 is, oh, my cat is just annoying today, 80% of 5. So 4 is more than half of 5. So that makes sense, right? This one is more normal. That's more like the kind of thing I'd put on the final or on the quiz tomorrow, like just a chill one. It's even tricky, like some people might forget to move the decimal over 2 places. I mean, it has its little tricky side, but so here, instead of eq, I could continue this one. So back up here to this. That's okay, Deanna. Where are you? I don't know. We want to move the decimal to the right. So it's going to be 6, 6 going on and on and on. Percent. No, it's not right there. 2 to the right. Sorry, my bad. I was doing too many things at once. And that bar is, I just shoved it over the whole thing, but then 0.666 repeating. If we know, like 0.3, 0.6 repeating equals 2/3. 0.3 repeating equals 1/3. Those are the most common weird ones with that repeating decimal that we can write as a flat out plain old fraction. But it's really hard. So this one is 0.6666 repeating percent. So that's why it would be 2/3%. So you can get the answer that way too. But it confused me too for a minute when I was trying to help someone yesterday. I was like, oh, if anybody did it that way, they just would be like, what is going on? So that's the other way that these could be done. A fraction percent changed into a decimal. I don't remember what number it was on the homework. Oh, sure. I'll make one up. If anybody, this is a question that just came in. So this is another question. Let's say if we had, we want to change 3/8% to a decimal. So there's one that's not the one that was in the assignment, but that's okay. So 3/8 changes to 0.375%. And now if we're taking the percent sign off, we go that way. 2 places to the left. 0.00375. That was a really good one too. Let's practice another one like that. So remember 1%, and I didn't teach this lesson, so you might not remember this. That's okay. 1% means 1/100 or 0.01. So 1% is very small. So if I said 1% of the OLC students are sick with COVID today, that would be good news. That's a pretty low percentage. I mean, not great news because still some people are sick, but it's a lower percentage than like 80%. 100% would be everyone. So we wouldn't want that. Anyway, so 1% is very small. So 3/8% is less than half of a percent. So it's even smaller, very, very small. So those are kind of strange also. Let's do a 0.5% to a decimal. 0.5% to, well, I'm going to put it to a fraction and a decimal just to show you that we can write percents as fractions and decimals and in percent form. So that's why we have to cover it again in this class, because it's confusing. It has a lot to it. And although people probably learned this before at some point, it's easy to forget if it's been a while, if you've been in high school or college and not doing these. So 0.5% as a fraction is that. And then what if I wanted to change that to a decimal? And if you have a calculator that does it for you, great. I have no problem with that. But if you want to just be able to do it calculator free, this is called a complex fraction now. I put a 1 underneath the 100. So it's easier to see that we're dividing the top fraction by the bottom, which means multiply by the reciprocal, which we've done before. So it's 1/200. That's still not a decimal, but I got it to a simplified fraction. So 1/200. Now we could change 1/200 to a decimal using a calculator, but I'm going to show you another way. But one top divided by the bottom in the calculator, and just write what the calculator gives you, because we already got rid of that percent sign when we stuck this 100 underneath it. But let's say if we had to do this by hand, my decimals are tenths, decimal places, hundredths. 200 is already bigger than 100, so I would go to the thousandths place, just so you'd see the idea. So over 1,000, if I could get this into an equivalent fraction. And then I can write that in decimal form if I'm comfortable with those. Like 1/10, here's 1/100th, here's 1/1000th, etc. It goes to 10,000ths next. So those are our place values on the decimal side. So what was my original problem? I had 1/2%. So 1/2% equals 0.005 or 1/200. See, so it could be in decimal form, fraction form, or percent form. That's a lot for people to take in usually. And since I didn't do the lesson yesterday, I'll just go over, someone else asked some more questions. I'll go over as many questions as you all want. Oh, thanks, Eileen, for some words of encouragement there. Put you down. And we got answers from, okay, we got everything caught up. Okay, so Eileen asked 2 3/10% to a fraction. Is that right? Oh, okay, Hannah, I'll check that next. So Eileen, I think, asked this one. Just make sure it's that I copied it right. Is that how it started out? I think it was Eileen. Let me see. Yeah, Eileen. Okay, so this is kind of that same steps that I was just doing before. Oh, wait a minute. There's an easier way for this one because it's in tenths. 2 3/10 would be that percent. And then that would equal 2.3 over 100. That's how we can drop off that percent sign as soon as we put that 100 there. But I have not taught this in this class that I think of. I don't think so. We are not allowed to have a decimal point in a fraction. No one ever taught me that until I was a teacher. And I was a math major too, which is so crazy that happened. But you're not supposed to have a decimal point in a fraction. So the way that we get it out of there, like you can just move it to the right, move it to the right. But what we're doing when we do that, in case you a critical thinker, which is good, multiply by what's going to get the decimal off to the side. And then you do the same to the bottom. There. So that would be 2.2 3/10% as a fraction. And then you'd reduce it if it reduces, but 23 is prime, so it won't reduce. And then I know too, like I was just saying, I could write it as a decimal. They didn't ask to, but it would be 0.023 because that's the tenths, hundredths, thousandths place. Good questions. Thanks. Look at your work if you have any other questions. Does anyone have any? Someone texted me one, so I'm going to look at that. But you could pull open your WebAssign if you did the WebAssign already. And okay, here's someone asked these two. Let's put them up. Oh, I hate this one. I should have taken this one off of the assignment from last time. It's terrible. They have this, they think that this makes it easier, but it makes it worse. And they ask what percent is shaded. What percent? I'll shade them. And if you had a slightly different one, that's okay. You'd solve it the same way. They have this shaded. Thank you very much for this one too. Good questions. So people are always like, what's with the 1/4 and the 1/2 and why is that even there? And they shouldn't be. It makes it more confusing. So ignore those. All those are there to say that all the squares are the same size. All the squares or rectangles are the same size. Then we can use our old fraction knowledge by just putting the number for the part, how many are shaded, over the total. That old classic fraction concept. So at 3/8 is shaded, 3/8 of the figure. And then we got to write it as a percent. So think about that. If you didn't do that one yet, then you could do it now and get some extra credit while I let my noisy pets outside. Just a sec. You can, but then just don't be so noisy. You can go out there. It's getting hot though. There you go. Love you, sweetie. And this, you might do it 2 different ways. So you could do it this cross multiplying way, and then here's the quicker way of doing this. Multiply the 2 that are present on the diagonal and then divide by that one. So you take 3, and this happens a lot in science class. You might have done it before, solving a proportion. 3 times 100 divided by 8, and that'll be your answer. So it's 37.5%, which is a little more than a third. And we can look at the picture and be like, okay, it's a little less than a half, a little more than a third. I'm convinced. Someone else usually about half the class does it that way because they learned it that way. Half the class takes the 3/8 and they get 0.375. And then they move the decimal to the right and put the percent sign on. See, it takes about the same amount of steps, and people are usually really comfortable with one way or the other. It's fine whichever way you want to do it. Any questions about that one? I updated the extra credit in the Gensbar gradebook too. Woo, some people got a lot of extra credit. Which means you might notice that as you get towards the end, I'm not encouraging you to skip assignments, but you'll see that you can't skip the final exam. But you probably, some of you would be okay if you skipped one of the assignments or even 2, so you could calculate what your grade would be if you just skip some of those. But again, not that I'm saying that you have to, but if anybody's under a lot of pressure or trying to do Sundance or family activities or funerals or reunions, plus all this, when I wouldn't hold it against you. In fact, when I see people like former students, not that you might not even care about this, but when I see people, like I just saw a former student at Walmart on Sunday, and I don't even remember what grades they got. I remember if they finished the class usually, but I remember their name if on a good day. No, I usually remember their name and what they were like in class, but I don't remember the grade. To me, I know a lot of people, it's important to them, their grades, but I think the learning and the interaction and the discussion and participation are more interesting to me about school for me as a student too. And so I'm just letting you know, if I run into you at the store someday or at, I don't know, a wonderful powwow in Denver or something, I'll just be happy to see you. Although now, because of COVID, you never know if you should hug someone or not. You're like, and I know the tribe still had the mask rule all the way up until recently, even in other places. So be careful with all that. All right, any questions about that one? That same person asked about a discount rate problem too. So let's see. I'll make up a couple, okay? Let's see if we've got a top was $20 marked down, which is a discount. 10% off sale. We want the discount rate is that 10%. The discount amount is how much you're going to take off. Whoops. And the sale price is going to be the new price. So first, what's 10% of 20? Anybody could just say it out loud or answer to me. And I'm going to show how to find it in case anyone didn't know. 10% as a decimal times 20. And I also know, and some of you would know already too from the past math classes, that 10% of something just moves the decimal one to the left. Good. Yep. So that's going to be, the discount rate is the thing with the percent. The discount amount is $2. And the sale price is the original price, the OG. So the original price minus the discount amount would be 18. So they sometimes give you a problem where they have some of those showing and you have to find the other ones. So I'm going to do another one that's harder from the textbook problems. I give you a little table to fill in. Let's see what I mean. Here we go. And there's also markup, which is the same kind of process, but that's when you're adding on like bootleggers do, or whoever, they buy something or convenience store people do. Not that I'm saying that those are like bootleggers, but some of the convenience stores way far out in the country really have a huge markup because they can, and because they put in the gas money to go get the products, and they can because they know that their customers don't want to go drive that far. So nothing against convenience stores, but that is another place where you see big markups. There's big markups in at like Walmart too. Yes, that's what I'm looking for, Miss. I'm trying to get one that's an actual problem in here so I don't make it really weird. Okay, so here we want one that has the original price and the sales price. So I'm going to grab one from the book here. Okay, the original cost, this is still a discount problem. Is 50. And the sale price is 30. And you have to find the discount amount and the discount rate. That's probably the hardest that they get. And then we'll do a markup one too, because a lot of people in college, like you're not all young, you might have had work in sales already. A lot of people in college haven't done a lot with markups themselves yet, but some of you might have. So the discount amount is just subtract the original minus the sale price, like how much money off? How much off was it? How much did they take off? Oh, whereas most people in college have gone and shopped sales. That's where I was going. Like we've gone to sales like at the mall or wherever. So that's the discount that they took off. And then the discount rate is that 20 over the original. And we want to change that into a percent. So whenever we see the word rate, well, in this section, whenever we see the word rate, we're looking for a percent. So 20 over 50 is 2/5, which is 0.4, isn't it? So that's 40%. 0.4 is 40% off. That was it. You don't have to put the off. That's just, I'm saying that there just because that's the way we say it when we're in the sale or we see it on TV on a commercial or whatever. 40% is almost half. So the more that we think about fractions and percents with their benchmarks, like what's it near, like get kind of a ballpark idea, the more we can reason more easily without having to write it down or grab a calculator. So that would be that one. And like I said, I'll do a markup one, but does anyone have a question about that one? And we can do some other ones too, like find 8% of 12, 7 is what percent of 42. Like we can do a few like that if one wants to. Like the more just plug and chug kind of ones. But we've gone through a geometry one, a story problem kind of one, the tricky one, some fractions. Those are really good questions. You all really have brought up all the things that usually people struggle with. Okay, here goes a markup problem. Let's see, how about if we do the cost that they bought it when they say at cost. Let's say it was $72. And then they're going to mark it up and sell it for more so they make a profit. So let's say they're going to sell it for not much more. Let's say this person is just going to sell it for 90. Try to account for, see, like right now, if gas is $5 a gallon and you go to Rapid City, like my car, if it's 100 miles to Rapid City, and my good car gets 25 miles per gallon. So I get, I need 4 gallons of gas times 2. So at least 8 gallons to go to Rapid City once, and it's $5 a gallon. So it seemed like if I had a store and I was gonna do some marking up, I'd probably mark it up big time right now, which people are doing, of course. So anyway, this is a small markup that I just made up, but that's okay. So now they're gonna ask, what is the markup? And whenever they say that, they're asking the amount. They don't write the markup amount, but so how many dollars did they tack on to it? And then from that, we can find the markup rate. So I just want to show that it's very much like that last one. So first of all, tell me what's the amount that they added on to sell it for? Okay, everybody, it's not that hot out. You all right? Yeah. All right, you can go out, just let me know. So the markup amount is going to be the selling price. We call it the SP sometimes, minus the original cost. So it's going to be 90 minus 72. So that's $18. Good. So they marked it up 18. And any of you, I mean, some of you, I'm sure some of you have worked in stores or have family members that have worked in stores. I'm not going there with the bootlegging, but no, I'm just kidding. But I mean, I even had a friend who was a professor at OLC who would buy all her cigarettes somewhere like online, like from Russia or something. And then she would joke about she could have bootlegged them, but she didn't. I mean, then there's taxes. You can't just go to Mexico and buy a lot of cheap stuff and come across legally. They'll try to get you. But anyway, I'm sure some of you have worked in stores or in bookkeeping or in businesses that do have this markup to make a profit. All right, then the markup rate, just like with the discount rate, is 18 over the original cost. You always go with the OG for that, the denominator. And then we want a percent eventually, so we're going to get a decimal. I just made this one up, so I have to grab my calculator, or I would do that proportion way to solve this too, but I'm just going to go 18 divided by 72.25. And that was a lucky chance. I made up those numbers and it came out. But usually if I make up the numbers, they come out really twisted. And then we want to change that to a percent because it's a rate and we're looking for a percent, and that's what they'd say. Oh, 25% markup. I had a student from Chadron State when I taught there a long time ago who worked at Walmart in the magazines, and they said the markup for the magazines at Walmart is huge, like way more than 100%. Which means, like, say they buy the magazines for 40 cents each and sell them for $8 each, like that. Like, it's a lot. It's more than twice what they bought it for. So anyway, that's the markup rate. Any questions about that one? What we're going to do this before we go on. We're going to practice. There's three kinds of percent problems, the basic cranking out a percent kind of situation. So we'll just practice 2 of each. So this is for, I'll pause the recording and you can write it in your notes and send it to me, or send it to me in the chat just for extra credit. But there's this kind. The easiest kind is find a percent of a number. So that's like if you're finding the tip or a tax, right? Let's say if tax was 8% of non-food items that they buy is $30. So that's one kind. I'll make a little mark around them. The next kind, the next easiest in my opinion, is like 14 out of 14 is like, we did one like this, but a harder one. What percent of 70? And how about 30 is, here's a weirder one. What percent of 20? So 30 is bigger than 20, so it's going to be more than one whole. So there's those two, that kind and that kind. And then the last one is So we have 15% of 40, 8% of 30. This, we know the percent and the part, but not the whole. So these are the last ones that I'm going to put up, the last two, and then I'll come back to this page. $25 is 12% of what? So that, to me, I think that's the hardest. And I'll go through the steps to solve any of these too, of course, all of them. And let's do 95 is 50% of what? There, that's the third kind. So you see, all of these percent problems have a part, the whole, and the percent. So they all have three things. So there's going to be one missing number. So that's the three types. All right, like I said, I'll pause this and give you a couple minutes to do this. Stretch and walk around a little too if you want. I'll give you a little more than a couple. Record your points during the break so I don't keep you too much past 2 before having a break. So anyway, let's see that. So like I said, I think these are the easiest when you know the percent and you know the the total or the whole. So we multiply, change the percent to a decimal and multiply. So that's going to be, and like I was saying before, it's really good to make yourself stop a second and guess. Like I know 10% of 40 would be 4. 20% of 40 is a fifth of it is 8. It's halfway between 10 and 20%. So it's going to be 6. So if you have that kind of number sense, it could only help. It never would hurt. 0.08. And then you can, like my dad was a total nerd. And that's kind of fun stuff we'd do in the car, calculating miles per gallon and stuff like that, and rate of speed and things, distances. So if you like those kind of things, you can do that with your family. And they'll either be like, oh, and put their headphones on. Like we used to roll our eyes, oh, not again, but like deep down, I loved it, I think. This one came out to be 2.4. And one of my best friends, her dad would make her do, not make, he would just give her little number puzzles to do in her head, like, like 75 plus 50 or things like that. And he taught her all these little techniques to do all this mental math. And some teachers will teach you that at school, in school, some do, and some don't, because it's hard to, you can't really test mental math. And some teachers aren't very good at mental math, and that's okay. But those techniques are really handy. Okay, now I'm looking at what part of 70 is 14 really? Like 14 is what percent of 70? So 14 divided by 70 is what is happening with that one. And you get 0.2 or 0.20 and then change it to a percent. So when it says what percent, we want that percent sign on it. So that would be the correct answer, 20%. Same here, that some people learned is over of. Some people learned the triangle, like that. So you might have learned lots of different ways. I try not to teach all the different ways, because some people might have learned the ratio boxes. My kids taught me those when they were in school, because I hadn't learned them that way. Well, you're close, close. So 30 divided by 20 is what's happening here, which is 1.5. And now I got to change it to a percent. So move my decimal 2 to the right. So it's 150%. Since 30 is bigger, the part isn't usually bigger than the whole. The thing with the of is usually the big part. Total right there. It's usually the biggest. That's why in the triangle it's here, down there on the bottom. Oh yeah, you're right. Uh-oh, I just erased something. I don't know what I erased. Yeah. Somebody just said, I learned that is means equal. And yes, because look, let's look at this one another way. This is actually how I was taught these. You would write it. And you can do it this way too. It's your option. I hate to give a whole million different ways to solve something, but 30 is what percent of means multiply a lot of the time? 20. There. So that's another way to solve those. So we want to get x alone, divide both sides by 20 to work on getting x alone, So that definitely works. And yeah, I was taught that way. And then there are places like if I teach foundational studies at OLC, we're not supposed to stick any algebra into it yet because officially people haven't done algebra. And this turns it in, when I do that, it turns it into algebra. So, but that is correct. Good job. That's is and of is that multiply. So x percent equals 1.5. So we can go that way too. So we still have to get the percent off of it. So multiply both sides by 100. 150. So that would be that one. 150%. Good question. Any other questions or comments about those first four? Oh no, I didn't mean to rush anybody. I'm sorry. Let's give it another. I'm just gonna pause right here for our break. So let's come back at 2:15. So if anyone didn't finish these two and the extra one, this is really extra. Like it won't be on the final or anything. And I have most of my advanced math students wouldn't be able to do that either, unless they've worked retail. So that one turns out to be kind of a puzzler. But I'm gonna pause right now and then we'll be back at 2:15, okay? So just take your break down, then we'll go over these after. Hello again. Give me some kind of a signal that you're back, or turn on your camera for a sec. Just so I know I'm not alone here talking to a screen. Thanks, Deanna. Thanks, Shanna. Dawn, thank you. Thanks, Tommy. All right. I think I've told you got this class, but maybe not. But after the first few months of teaching on Zoom, I had this really bad dream that I was standing in a trailer way out, like up on North Route somewhere, and standing there at a big screen TV, a real TV that was on the wall, but it was off. Just a big black off TV. And I was standing in front of it, just yelling math things at it. Can you hear me? Like math stuff to this TV that wasn't even hooked up to the internet or Zoom. And that was a dream. I'm not really that nuts, but when I woke up from that dream, I realized, I'm gonna have to balance out this online teaching with some in-person stuff. So, and that's when I started like working at the state park in the summer and teaching Tai Chi and teaching karate and working at the local natural food store, just so I could ground people a little, even though we weren't really supposed to. We were forbidden from being at gatherings, like a lot of people were, but our boss forbade us from from being at any kind of gatherings, but and so I tried not to be anywhere that there was more than 6 people. But some people are fine just being alone, talking to a screen. I have friends who love working from home, but some people just need to have people. And my kids are all grown up, so my kids don't live here at the house. My partner was an essential worker, so he was always at work. Even, I mean, like the first month, maybe he worked from home of COVID, and then he went back up and worked for the tribe as an essential worker. So I just was here with the pets, with the screens. Sounds like a scary movie. We just finished watching Stranger Things last night, so I'm still a little spooked. But anyway, so let's say that what if we did this one, that equation way? 25 is 0.12, that's 12% times X. That works. You could set it up that way and solve it, or you could say 25 over what equals 12%. Those are the two main ways to solve these. So there's that way or that way. Either one is perfectly fine. That one came out to be a weird one though, because I made that up off the top of my head. So it was 208 1/3. So that was not my best. Ended up with 2,500 divided by 12. It didn't come out really steadily. You could have said 208.3. I'll accept that too. So that's fine. And then 95 is half of, that one's easier. It's half of 190. And then this one, it's you should have ended up with 2,000%. That's the answer. And if anyone wants me to go through that with them, I'll show you. I'm just going to write it down so I don't forget. And that was that magazine markup problem that I made up. If you're selling a magazine for $8, but you bought it for 40 cents or less, they might even buy them for less than that. So my first boyfriend in high school, his dad worked for a big magazine publisher in New Jersey. And their whole house was just stacked with magazines. And any kind of magazine you might want that publisher did, he could get it for us. So like I was actually in a magazine once when I was in high school. I had got a makeover on 17 magazines. So that my boyfriend's dad got like 25 magazines, just gave it to our family so we could give them to people. So dorky, but it's true. All right, any other questions about the percent problems that anybody might have? The rest of what we're going to do today is much easier. We'll see how much I can cover today. I'll just go until, like usual, till about 3. If I don't get all the way through everything I planned on, that's okay. There's time tomorrow. And I won't put it on the quiz if I didn't get through it today. So tomorrow is a quiz. That's our last quiz, quiz 3. And I'm going to use a quiz that comes with the textbook. So quiz 1 was on WebAssign, remember? Quiz 2 was on paper. It was in Moodle. And then quiz 3 is going to be a textbook quiz. I'm going to put it in PowerPoint form, I think, and just go through it during class, like show the slides and give you time to work them. And then if anybody happens to be absent, I know there's a lot going on, like I said earlier. So if anyone's absent and needs to make it up, you can still make it up. I noticed when I was doing the grades, I just thought of one thing. Let's see, that activity that we did on day 5 with a partner, a few people didn't get to do that. They were going to make it up, and then I forgot to pair them up with someone and give them a chance to make that up. So Friday in class, Friday is just a catch up and review day. So during class time on Friday, if you still need to make up that activity, that was that graphing activity. So, or if you're wondering if you're one of the ones who didn't do it, just ask me, or you can look on Jen's bar, but you can still make that up if anyone wants to. I started rambling on about all my weird stories of my life. I grew up in New Jersey. I think I told everybody that the first day, right near New York City. Like you could walk to the top of my street and get on a bus and be in downtown New York City in 30 minutes. And it was really cheap back then too, just a couple bucks to jump on. So my friends and I, as soon as my parents let us, I think we were like 15, they started letting us go into the city in the day. And that one, we were kind of lucky. Could have been, I don't know if I would have let my girls go do that. But anyway, ratios and proportions are, a ratio is a comparison of one number to another, and we've just been working on some already. So you'll see that's not going to be very tricky. You could write it this way, 7 to, let's say 7 to 21. Or like we see it in odds, like even on a cereal box or a lottery ticket. There, your chance of winning is 1 in a million. That would be, people see that it's written with that dot, 2 dots, that colon, it's called. So 7 to 21 means the same as, oops, not 1 yet, 7 over 21, or 7 to 21. And we can reduce it to 1 to 3. So these are just the different ways that you could write them or say them. But yeah, like on a scratch card, like, or on a cereal box, like a prize situation, those are those odds. That'd be 1 in a million. A horse race, car race, those kind of betting races. So dog races, I guess. I've always wanted to go see the traditional horse races someday. I don't know, do people bet on those? Probably, huh? And the stock car races, oh, those are fun too. But anyway, so ratio is a comparison. A proportion is one ratio or rate equal to another ratio. And proportions are like, let's say if we had a picture that was 3 by 5. And we wanted to make it smaller, something to 3, let's say. Oops, I wanted that to be use a different number than the 3 and the 5, so it's not confusing. Let's just shrink it down to something by 4. So we could set up one ratio for the first picture, and then the shrink, the long side is 4. And we can solve that. So that's a proportion, one ratio equal to another one with a piece missing. And those are used like in similar triangle problems, like we'll do a few, or school situations. I'll show one of those too in just a second. Like if you're I forget, when I taught in a Title I school, it was like one teacher for every 10 kids or something. So let's say if it's like that, one teacher for every 10, I'll do that one. And then you have like 300 students. How many teachers do you need? Like that kind of situation comes up a lot in school, or in medicine, it comes up. Like if you have a certain dosage for 100-pound person, then what's the dosage going to be if the person's 150 pounds? Like those kind of situations. It's really good real life problems that come up. But anyway, that's what a proportion is. One ratio equal to another. And we, like before, we multiply the 2 that are there on the diagonal, divide by the one that doesn't have a partner. So it would be 12 divided by 5, 2 2/5. So that would be 2 2/5. And then watch your labels. So it's going to be inches if we started with inches. Or 2 2/5. Remember, you could write it as a decimal also. That would be 2.4. So there's that also. So that's what a proportion is. So a ratio is one of these, like this. A proportion is the two working together. Let me go on to that other example about, and I haven't taught in a Title I school in a while, so I don't remember the rules. Does anyone know? So I'm just making this up right now, since I don't know might be every 8. Special ed is different too, you know, one teacher for every 10 children in a school. A school has, let's say they have 240 children. So then we could figure out how many teachers. So these are really wonderful for story problems too, because they're pretty simple. I mean, they're pretty straightforward, not too wordy, but still it's hard to, for people who aren't used to it, it's hard to get comfortable with what goes where. So what number goes where? And so one teacher, I'll put T next to it. Oh wait, this is only one way that I've done this before. Teachers to kids. Wakaija, right? 10 kids. So that's the setup that they give you. And then a school has 240. We need to know where to put it. So it goes on the kid level, children. And we want to find how many teachers do we need. So again, we always solve these the same way as far as I know. Multiply on the diagonal and then divide by this one. So tell me, what do you get? And then your answer is always going to have that label, whatever they were asking. So I suggest just putting the label there before you even do the math, because then you'll have it. And then if you had to jump up and answer the phone or run out and stop the dog from eating a snake or whatever is going on in life, you know, life goes on, and sometimes our math problem is just half done. Good job, Tommy. That's it. Yep. So we set ourselves up for success as much as we can, you know. Let me get back to my extra credits. Yep. So 240 divided by 10. So it's going to be the diagonal we multiply, then divide by the one that's unpartnered. So it's going to be 24 teachers we'd need. If we got, like, not in this case, but if we had gotten like 17 and a third teachers, whenever we're talking about humans or animals or vehicles, we round up. So if there's, and they'll say so on the question, they'll remind you to, we'll round up to 18. Because, or you, I mean, in a school situation, you might hire 17 teachers and then have one teacher just work 1/3 time. You know, I mean, that as a school administrator, like have one teacher just work 15 hours a week or something like that. But that might not work out in every school, that situation. So just remember to round up if you get a fraction of a person. Otherwise, I mean, you might see sometimes they'll show like those little pictographs. There's the people. Sometimes in the paper they'll show this, like USA Today, and then they'll just have a half a person like that. That's not very realistic, but they do sometimes do that. But we're not going, we just round up to a whole person. Any questions about that, anybody? So we could practice some of these. They'll just say simplify the ratio, simplify. And some of these are easy and some are not. So let's say we had 27 to 63. 5. Oh wait. I'm going to change up my 5, 2, 2. Oh, that's not going to simplify at all. Let's say to 2.2, that'll be exciting. And then we could have 3, this is a hard one, 3 1/5 to 5 3/10. And maybe something different like $40 to $60. There. So I'd simplify the ratio. As long as they have the same labels, we can reduce them like fractions. Or these have no labels except for number 4 has a label. So the method to do this, let me do the harder one. We first write it as a fraction with the first one always on top. And then like before, we can't have a decimal in a fraction, so we're going to multiply by 10 to both, so the decimal is gone. Well, the decimal had moved over to here, but it's not showing. Just like with money, we don't show it. Like with these, I didn't write 60.00, although that wouldn't be wrong either. That would be wrong, but we don't always have that decimal in there. Anyway, this one wasn't quite finished though. Here we go. And then reduce, like 2 goes into both of those. So you can leave it as a fraction, or you can go back to writing it with the colon, the way it was originally handed to you. This one had the colon, the 2 dots. But in WebAssign and in your book, they leave all the answers as fractions. So that's why I put a box around that one. You can send me 1 and 4 if you want to. I'm going to do 3 next because that's hard, a little bit harder too. I changed them to top heavy improper fractions. So there's 3 1/5. And here's 5 3/10. And then that's what I called before a complex fraction. So take the reciprocal of the bottom fraction and multiply. Now I'll pause it for a couple minutes in case people are wanting to do those before I show the answer. Oh, sorry, I was talking with my mic off. When we're making a ratio, we're thinking of 2 numbers comparing to each other. So it's a little different from the fraction idea of a part of a whole. It's more like apples to oranges, dogs to cats, comparing 2 very different things. Sometimes they're the same label, but it's like 2 separate entities, not a part of a whole. But then we end up writing it like a fraction anyway. So it's a little bit of a different idea. But like I was saying, teachers to students. Now this one person sent me this, which I'm so excited about. Reciprocal of the bottom fraction. So it's like a fraction division when they look like double decker. Cross cancel. Then do your multiplications carefully. That would be that one. And this one's 40 to 60. Reduces to 2 to 3. The dollars, the labels, like right there, sometimes they cancel off. So like in this section, if it was inches to inches, same thing. The label cancels off. So the final answer doesn't have a label. That's a little confusing too. None of this is super complicated, but it's just little subtle confusing details to watch out for. And this kind, those mixed numbers or the ones with decimals, they're probably the trickiest, huh? Any questions about those ones? So sometimes we can have different labels on them. And then we'll do a couple geometry looking ones that will probably be done today. Well, I thought maybe I'll show you the 3-6 topics just to get a feel for them. But where are we? If I had some examples like this, 80 inches to 5 feet. Don't be tricked by those. Let's do one that has metric also. 75 centimeters to 2 meters. And one that's with money. 7 nickels to 3 quarters. These are still ratios, but just a little bit trickier because we need to make sure that they have the same label before we do the math first. So one of them has to get converted. I always say convert whichever one's easier. So in this one, I'd say it'd be easier to convert feet to inches. And then go ahead and put this one on top, 80 inches to 60 inches. The label can cancel. Reduce the fraction. And we don't write 1 1/3. We leave it as a top heavy fraction. So that would equal 4 to 3. So the 80 inches is the 4 parts to 3 parts. You know, if you make a salad dressing or a punch and it's like salad dressing is, I don't remember, 2 parts. Well, when I cook rice too, 2 cups of water for every 1 cup of rice, that kind of thing. So that's a perfect example of these sort of ratios. So this is 4 parts. That one represents 4 parts and that's 3 parts. But when you see the 80 and the 5 at first, it doesn't seem obvious. Then go to the metric one. 1 meter is 100 centimeters. And all these conversions are, I'm going to put up a page of them on the Moodle because they're in the back of your textbook if you have the hardcover book, but or maybe the front, the back, they're on the very back cover, all the conversions. But if you don't, people could look them up too, I know, or a calculator app will do it, or there's a lot of ways you could do conversions these days, but I'm just gonna go ahead and put a sheet up on the Moodle in case anybody doesn't have the hardcover book. So that's 75, oops, not the equal, to 200. Now they both have the same label. So I can write it now, I can write it as a fraction and reduce. 4 and 4 is 8. So that would be 3 to 8. And then the last one, I'll go on the next page for, but that one we don't write 7 to 3 because even though they're 2 different things, and I was just saying we're comparing different things, we can convert them both to how many cents are. So we could convert it to cents, and then we could get rid of those labels. Because like it wouldn't be wrong to write 7 nickels to what was it again? 3. Yeah, 3/4. But then we'd have to stop there because the 7 and the 3 can't reduce, and the nickels and quarters are not the same label. And our goal is the same label if we can, if possible. Like, it isn't always possible. Miles per gallon is a perfect example. That doesn't, miles per hour, dollars per hour, those kind of things, they stay that way. So sometimes the labels can't reduce. But I'll show one like that too. But this one, we can change them to cents. 7 times 5 cents over 3 times 25 cents is 35 cents over 75 cents. And then reduce 7 over 15. Is that right? Let's see. Yeah. And the label goes away. So see, those answers are a little bit weird. So just be on the alert. Anyone have a question about those? Like I was saying about the miles per gallon, like these could be really useful. Say if I went on a trip and I went 800 miles, and I used, I don't know, let's just say 50 gallons of fuel. What's my MPG? You can also push it further and figure out what am I going to pay if it's a certain cost, plus oil changes or the flat tire I had or whatever else. We can make it more complicated. But miles per gallon, my MPG is miles per. We usually, when we write that, we're thinking per gallon in this kind of situation anyway. So I did 800 miles per 50 gallons. And we're going to keep the miles and the gallons because they can't combine to have the same label. But we can reduce those numbers. We can reduce that fraction down. Who knows what that would come out to be? That was exciting. I don't know what happened. Yeah, good job, Kristen. Way to carry on. Remember, it was 800 miles for 50 gallons. I don't know if I just exited the meeting or what I was doing. I don't know what I was doing, but this is going to reduce. And 16 miles per 1 gallon. And we don't, like if I make $8 an hour, I don't write 8 over 1, so we would say 16 mpg. So that is not great. That is like my Ford Explorer gets, like an old pickup truck might get. Huh? That would not be the vehicle to take on a trip. Because also, like I was saying, we teachers could make the problem even more involved, but like in real life, it's important. Like say, oh, I want to go on a vacation, or oh, I have to go to a meeting in Mission tomorrow. That's a good example. I didn't even give it much thought, right? I'm going from near Chadron to Mission. I didn't really give it much thought until I was sitting down looking at the map, and I was like, oh, I know it's about 2.5 hours away, but I just hadn't thought about how much gas I'm going to need. It's $5 something a gallon, and all that math is going on. So it's pretty great. All right. Let's see, any questions about that? One of my favorite ways to work proportion problems is similar triangles, and this comes up again in trigonometry. Some of you probably had trigonometry in high school. And if we have, let's have this be 3 feet, 4 feet, that's a 4, and 16 feet. And I have to find that missing side. So these are called corresponding sides. They're both along the bottom. If the right angle is here, that just means it's 90-degree angle. So those are called corresponding. And so we line them up together, just like children to children in that other one, corresponding sides. So at least there is 2 ways to solve these two, but let's just say if we did those bottom ones, bottom to bottom, just looking at the picture, and then this is a corresponding side to the X. So we could set it up that way. You also could, honestly, if somebody's like, but I would have done this. Yes, that works too. It'll still get you the right answer. So there is one way that wouldn't work. If I did 3 to 16 equals X to 4, no, that would be not right. That would be not good. That would be going across the diagonal to, wouldn't work at all. But sometimes it's not obvious to everybody how to set these up. So if it's not obvious to you, just do like I did right down here, the bottom to the bottom on the bottom of the fraction, the side to the side on the top, and then solve it like normal, cross multiply, divide by that. Tell me what you get. You can find the missing side. Also, we know just by looking at the picture while you're thinking about it, that missing side is going to be a little less than the base, because this one was less than 3 was less than this base. So this one, if they're similar triangles, which I'll put the definition on the next page. If you have similar triangles, that's always going to be true. Corresponding sides are proportional. I'll come back to that for the answer. Let me write that here. Similar triangles. Good job. Yes. Are proportional. Meaning corresponding angles, all corresponding angles are exactly equal, or we use the word congruent. And corresponding sides are proportional. Keep putting an S on this. There we go. So here, I'll come back to that. If we had this and this was a 90-degree, a right angle. Let's say, I'm just making this up right now, but let's say this is 60 degrees. This would also be exactly the same size. And that's 30. So the angles are exactly the same size. The sides obviously are not, but let's call that A, A1, B1, C1, and this would be A2, A2, and C2. We have these ratios are going to be true. A1 to A2 equals B1 to B2 equals C1 to C2. And other variations of that also, like A1 to C1 equals A to C2, etc. So there's a lot of proportion that we can make with similar triangles. And similar triangles don't have to have a 90, but in trigonometry, it starts that way. And in our book, there's a few in yours that don't have 90 degrees. So it's not required that they have a 90-degree angle, but those are like the sun shadow kind of problems and things like that. So here's that too, in case anyone wanted to see that. We'll do one that's a little bit harder. Two more problems. Let's see, it's 3 o'clock. Oh, that's perfect. Well, I might just go a little longer today. I know. So here's two more problems from this section, and then I'll just show you a few from the other section if anyone wants to go ahead and do that whole assignment, but I'll change the due date because the assignment that I have due for tomorrow has section 3.4 and 3.6 in it. And I haven't taught 3.6 yet, so I'm just going to show a couple examples in case anyone wants to jump into it, but it won't be required to complete this assignment by tomorrow, actually. So this is one of my favorites. A tractor, this comes from the book, requires 4 gallons of fuel to plow for 90 minutes. How many gallons are needed for 8 hours of plowing? That one's one of my favorites because it's kind of realistic. And it also makes us convert. We can't do it yet because we have minutes and hours. So we'll have to convert. So anyway, in these problems up here, they always will say something about the triangles are similar. Find the missing side. And again, similar correspond angles are exactly equal. That's what these little marks mean. Exactly the same degrees. And corresponding sides will be proportional. So we want to find the missing side so we could say, oops, like I was saying before, if we're ever not sure, just go ahead and say, okay, the bases of the triangles are there. This top left side is here and here. That would set it up. Go ahead and solve it if you are so inclined. That one comes out to be a mixed number. And that's okay. I'm really sorry about that. I don't know what I'm hitting. Let me see. I don't know. It's not good. So maybe I should stop the class, huh? Let me put the pictures back up. And the tractor problem. There, that was that one. That was one. The similar triangles. 15 to 10 equals 20 to x. And the other one was 4 gallons of fuel to plow for 90 minutes. So I convert that to hours. How many gallons of fuel for 8 hours? I would set that one up that way, but if you did it slightly different way, that's okay too. Then we'll call this, just call that G for gallons. Oh no, it looks like a 9. Let me call it something else. V. So V is going to equal 4 times 8, and it'll be gallons. Divide it by 1.5. So that would be how to solve that one, that diagonal, and then divide. Be careful what I hit. Hitting an invisible exit button. There we go. Okay, here's our, and the diagonal C is sometimes in a different direction. So that's going to be 200. They didn't give labels in this problem, so we don't worry about it. It's just say units if it bothers you. 200 divided by 15. I think $13 1/3, that one comes out to be. So that's what x equals, 13 1/3 units for number 1. Does anyone have a question about that one? And this one's going to be 32 divided by 1.5. This one has a fraction answer too. It's 21.33 or 21 1/3 gallons are needed for that situation. So those are probably about as tricky, in my opinion. That's just about as tricky as these get. Instead of going on to the next section, I'm just going to show a couple of the straight algebra problems where you might see in your assignment. Let's see if we had to do one like this. So we haven't done one like this yet. And here's another one that has more business going on than just that cross multiply then divide. So we'll do those two and then I'll stop. In a proportion, when it's true, if I have like A over B equals C over D, then A times D always is going to equal B times C. That cross multiplication, the cross products, are always equal. So like we know like 2/3 is equal to 4/6 from long ago. You've done that before, but here's the with the actual numbers. 2 times 6, 3 times 4. The cross products are equal. Product is just the answer in a multiplication. So we've already been using that principle to solve those proportions that we've been working on, but this is why, because in any proportion, those are just representing the numbers, then A times D equals B times C. always going to be true. And there's other stuff you can mess with also, but that's enough for that. So backing up here, we should be able to use that principle to solve these. So here's this one. It's going to be 10 times x plus 1 equals 5 times 3. And then as soon as we get to there, you all have a lot of experience solving those now. I'm not too worried. Good job. Beat me to it. Yes. So in that one, for example, x equals 1/2. Or 0.5, just read the instructions on WebAssign if it asks for your answer in a decimal form or fraction form. So that'd be the answer to number 1. This is a different problem. I'll put it on the next page. X plus 6 over 3 equals x minus 5 over 2. So these are clearly proportion. When it's obviously a proportion, one fraction equal to another fraction, we can solve them by cross products that way. So that works with proportions anytime. But if I had like 1.5 equals 3x over 6, that I can't do, like, that isn't going to work. Like I'd have to make sure they're both in fraction form. Or if I had like 3 plus a quarter equals x over 7, I can't just like focus on that and ignore that. Like I can't do it then. But here they're both exactly in fraction form, even though they're kind of cluttered and weird. But we can handle it. Cross products. 2 times parentheses x plus 6. Keep those parentheses on there at first, so we remember to distribute. And then the old equation solving skills come along. Negative 1x equals negative 27. So x equals 27. See, that's not that easy of an equation, but the steps aren't too bad. It's just a little bit different of a feeling. So, oh, good. I love these because they are really useful. Like I was saying before, like especially in medicine, in building things, in schools, like in driving, like in our lives, we work these a lot, or we do them in our head. But I wonder if we should do one more, or if we're okay. You're probably okay with that. Anybody have any questions? No, here's one more final exciting one. Last one. And then, like I said, I'm not gonna do 3-6 yet. So you could start your assignment. It has both sections in it, but you could start, but just don't do 3-6 yet. And then I'll just teach it tomorrow. Okay. So nobody's like trying to just figure out stuff in the dark. Well, I mean, I won't punish you if you try it, of course, but here's our last one to do. Then I really will stop. I've seen people that can do these in their head. I can't. There's a point where I can't. I have to write it down or I forget. I lose a piece usually. This one is pretty good too, because it's easy to make a mistake with the sign or to forget to distribute. So I've seen people do them like this and straight away write 7x plus 49. And then right here, 5x plus 45. So I just skipped a step. And then that goes over there. And then this goes over here. That's kind of a messy process right there. But it's not wrong. It's clear. Like if I had a student who showed their work that way, that's fine. I understand it. I would get that okay. So x equals -2. We could still check our answer like before. And we'll end up with 5/5 equals 7/7 equals 1. So that's it. Yep. Nice. I'm also going to talk about section 3.5 tomorrow. Usually I just do that all in one day because it's a lot of different formulas, and sometimes people I like to show like a lot of examples just so everybody's seeing all the different possible problems that they might have. Not like bad. Sometimes I wish we didn't use the word problems in math, because problems we think of are going to be a negative thing, right? But not in our situation. Okay, turn on your camera if you can and say goodbye, or send a signal. Start your next assignment if you want, but it won't be due until Thursday. Good work today. Hanging in there. Nice. So we're almost done now. Bye. Oh, stay on if you need to talk to me, of course, like always.